Okay, this is just a test. Let's see, there we go. Okay, a little look at the bird structure from all directions. There he goes, upside down, flying over, and there is a side view. Hi there, Charles Ford here. Right now I am working on a project for Secret Garden, which Merely Players Theater is doing in the spring. And the last time that we did it, I created a robin that was cable controlled. Basically bike type cable ran down the branch, down the tree and off to the side. And there were, I believe, four different levers that could do different controls on the bird. So this time though, that was, good grief, that was in the early 90s. So this time I wanted to make a robin that was a bit more personality, a bit more puppeteering for sure. So I'm creating an animatronic robin, and here he is. I started by doing a lot of research on how bird wings work, and so this was the first piece I made with, as you can see here, from the shoulder going kind of to the elbow, and then the let's see, radius and ulna kind of bone, and then basically a hand out here, a finger, I suppose. It's a 4-bar system. Once you see it on the real bird, this is 1 bar here, and then between that hole and that hole runs a wire that acts as another bar for it. And that is attached to a shoulder mechanism right here that can rotate. I thought it would make the most sense to look at it from the back going forward. I'm using little 9-gram Metal Gear servos for this. The rearmost one, I had to put it back there. It just got too full on the inside of the abdomen here, and I figured I could extend the tail just a little bit and have this guy sitting at the tail. An arm attaches on here, and there's a very, very thin cable control that runs from there through the abdomen and up into the head and actually into the back of the head, and it controls the beak here. It makes the beak go up and down. So that control is all the way in the back of it, and I am going to hide that guy right now. The program I'm using is Autodesk 123. It's a great program. It's free, and I've been getting better and better at designing things in it, and some things actually work the way I designed them. Moving forward, the next servo is here. It's a full-size servo. It's also a Metal Gear servo, but it's a full-size one. I tried using 2 of the 9-gram servos connected together to a pulley right here that would pull a string. This mechanism makes the wings extend and fold back in. And even though to me it felt like I wasn't using very much force at all to do that, the little servos just could not handle it. So I had to move to a full-size one, and this pulley, a braided fishing line goes from this hole right there across here into a hole right in here and is fed onto this pulley. And so both wings are pulled at the same time by that. And there's a lot more force there that it takes than really I totally understand. Anyway, there's a hole here. The braided fishing line goes around the pulley through a hole and then is tied off into a screw, a tiny screw that's screwed into the pulley itself. The pulley is 3D printed. Let's see, come on. Here we go, let's see if I can hide it. I had it, just acting a little slow, there we go. And then here's where the full-size pulley sits there. And I made a couple brackets for it, not 3D printed, but out of brass, out of flat brass. Because it was just too tight in here, I couldn't really figure out where I was going to totally attach it to, and the brass was much easier to rig. So we'll get rid of that guy too. Let's see, to hold the legs up, actually in a real bird, the hip is way back in here, in that area, way back up in here, and the femur would go from the hip down to here. But I really didn't need that. I didn't want the bird to have to extend that far, and so this is really at the knee here. This red piece right there is where a piece of brass goes through that hole right there, in and out through the other side, and that's what that right there is the tube that the brass goes through. Then a let's see, I think it's a number 6 bolt goes through here, and this is a part here that holds the nut in place and keeps it from turning around. I use Loctite on the nuts, and the brass tube that goes in here, you'll see this is kind of rotated from where it really is on him. If I rotate that, let's see, I think it's, yeah, there you go. No, that's not it. Wrong rotation. There we go. Okay, it's actually rotated down that way with the leg attached to it, as you'll see on the actual bird. So let's get rid of that piece. This piece is also 3D printed and attached onto the frame. It's kind of funky how it attaches here, but it had to stick outward to give me a little bit of room, and also to match the robin's body. So that piece goes there. Let's see, it's the same on the other side, as you can see over there. This servo makes the head go upward and downward. There's a very, very small cable that runs through a cable housing that goes up, and it's kind of a push-pull, but there's a piece of elastic that goes from the head down to the body for the pull part, and then this servo with an arm on it does the pushing part of that. So if we hide that guy, another servo sits right in here, okay, right there, and this guy does the head left to right. Same deal, a tiny little cable running up to the head, and there's a universal joint. I got it from a hobby supply for model RC cars, and so there's a universal joint on the head connecting it to the body, and then this servo can move the head side to side. There we go. The final servo does a wing flap, and that was interesting. I found an animatronic bird online that had this. I've tried different ways in the past. This bar right here is attached to these guys. They are printed in NinjaFlex, and it's attached to the bar here with a bolt and attached to the wing flap here, the shoulder, also with the bolt. And when this bar turns, when it spins around, when it turns 180 degrees, then it pulls these shoulder pieces inwards, and then when it goes back to the side-to-side position here, then it goes back to being out. It doesn't get quite the range of motion that I had wanted, but I think it will be enough, and it seems to be very reliable. This piece is the NinjaFlex piece. There it goes, and now you can kind of see the shoulder better there, and you can see the bar. It's really a typical a 9-gram servo bar, you know, that comes with them. But I just put one in there so I could see kind of where it would sit and if there would be enough clearance for it, which there is. So that servo is the one that does that. So away with it. You can see now kind of the structure of the body. We'll go up and kind of look under it. There's this back piece that acts to kind of hold the whole thing together. There's a tail piece coming back here to attach the servos onto. There are the ribs here that make the chest, and then there's this wishbone kind of shaped piece here that finishes out the bird's chest there. The holes here in this are for a piece of wire, a stiff, very stiff wire to thread through to hold the whole thing together. And you can see it's that this guy's kind of a piano hinge on here with that. So if we take that piece away, there we go, then we can see, you know, kind of how that sits. And the part that comes down here makes a very firm attachment for the wishbone, and these pieces, these rib kind of pieces, are attached on with epoxy, with an epoxy gel on there. So there's no physical one for there. This piece was really fun to make. Right here, it has basically a pulley here to thread the cable through. And then there's, as you'll see, there's elastic up there to hold that in. And then the hole here to go up to a rod, and a hole there for a little bolt to attach the other wing piece to. So we'll go hide that guy. And then over on the other side, let's see, there we go. Okay. You can see kind of how it goes together. There's a bolt here and a bolt there that hold those together. They are Loctited together with blue Loctite, and so that it can pivot, and it seems to pivot very nicely. And again, there's an elastic thread that acts to move it around. The head itself was basically a circle, and then pulled into an egg shape, and then cut, and then a cone for the beak, and then the cone attached to it, and then cut into 2 sections here. So for some reason, I'm not quite sure why, there we go, I was hollowing out the egg, and I think what I did is I didn't know if I had done the command correctly, and I did it twice. So the head itself has kind of a double interior shell, but that's cool because it's extremely thin and therefore really lightweight, but also pretty strong as well. The jaw here going into the head I put into there with a little nylon, tiny nylon hinge that again I got from a hobby store. It's used in model airplanes to hinge wing flaps on and that kind of thing. So that's kind of where it's all at. You get a good idea of that. So there's that part. Hi there, Charles Ford here. If you've watched this far, you must be interested in seeing the real bird, so let me show you that. It's a bit difficult to see, but right now I've got the control unit connected to an Arduino Mega. I am going to switch that to an Uno here pretty quick, or maybe even a Pro Mini, so I can put it in a small box and be able to use it that way. It is connected. The blinking thing there is an HC05, a Bluetooth control module, and then if we follow the wire down, we will find the Wii nunchuck that I'm using as control. The roll, pitch, buttons and the joystick all work together to do different types of control on the bird. As far as the bird's concerned, right now I have a drill battery, 18 volt, that's connected to a switch going to a transformer, basically, converter that converts it to 6 volts. Then there's kind of a whole mess of wires here that have to get cleaned up and soldered together. Way over there is a tiny little relay that I use to turn the power on to the SSC, to the servo control unit. There's an Uno right there, an Arduino Uno, and I definitely am switching that out to a Pro Mini, so it'll be tiny enough to fit inside the bird. Over here is the HC06, which is the slave unit. And then going up the wood here, we've got, let's see, oh dear, right there. That's the SSC that runs all the servos. It's very tiny, thank goodness, and all those cables go up into the bird. There he is. Okay, there he is. I can make the wings go upward and then flap. Okay, he can go down, look up, go all the way up there, and the head can go down, right or left, his left, right, back up again. Flapping the wings. Let's see, okay, roll that way. Look up, go back down, and then let's see, let's go up, wings down, up, head up, come on, there you go. Okay. Okay, right here you're seeing the bird. Let's see, I'm just kind of playing with the nunchuck. I'm still working on that. It's kind of a little bit difficult to puppeteer right now. But there go the wings up and down the flap. To do that, I turn the nunchuck like upward facing the ceiling and back down. You can see when I move it too much, the bird gets jerky, trying to do too many things too quickly. But there's some nice head movements there, back and forth. Those white string-like things you can see are elastic thread, a thicker elastic thread. Elastic thread comes in all sorts of thicknesses, and that's what you're seeing there. Pulling the jaw back down and returning the head to a center position.